Okay, students, listen. Last class that I have discussed about these problems. Just I will show it again. Any doubt is there, you can ask. Okay. This is the first problem. Whatever we have solved, go through this. Right. Okay. This is the second problem. Continuation. And third problem. This is the fourth problem. Fifth and sixth. Here n square is to be determined. Determine this value of n square. Then n is equal to how much? You do the calculation. Okay, yes. Write the next question. Write the next question, that is eighth problem. Question number 8. The energy of a linear harmonic oscillator linear harmonic oscillator in its third excited state is 0.1 eV. Full stop. Calculate its frequency. Okay. The energy of a linear harmonic oscillator in its third excited level. Means E suffix 3 is equal to 0.1 eV. Convert the 0.1 eV in the form of joules. Multiplied by 1.6 10 to the power minus 19 joules. Okay. So here n is equal to 3. H value 6.625, 10 to the power minus 34 joule into second. Frequency is how much? Now the formula E suffix n is equal to n plus half into h. This is a constant formula. Put n is equal to 3 here. N is equal to 3, you have to put into h nu. E3 0.1, 1.6, 10 to the power minus 19 is equal to 3 plus half. Is it not 7 by 2? Okay, you do it. Into h into nu. H is also known thing, but we are supposed to calculate this frequency. That frequency is equal to how much? You do the calculation here. Get the answer for nu is equal to how much? You do it. So many hertz. Do it fast. How much you got the answer? Frequency answer. Shall I write it? 6.895 10 to the power 12 hertz. Okay. Question number 9. Problem number 9. Write the next question. Find the momentum. Find the momentum and the energy. Find the momentum and energy values. Energy values for an electron. For an electron in a box. In a box of length 1 angstrom for n is equal to 1 and n equals 2. N equals 1 and n equals 2. Find the momentum and energy values for an electron in a box of length 1 angstrom for n is equal to 1 and n is equal to 2. Okay, this is the question. Now the data, whatever it is given in the problem, length is given, the width, of course, the width is equal to 1 angstrom. 1 angstrom can be written as 1 into 10 to the power minus 10 meter. 1 angstrom. H value, we know that 6.625 10 to the power minus 34 joule into second. These are the data. N1 is equal to 1 is given, n is equal to 1 and n is equal to 2 is given. Okay, yes. So the first concept, n is equal to 1. Here n is equal to 1, first one. Okay, for n is equal to 1, for n is equal to 1, now what you are getting? For n is equal to 1, P1 is equal to how much? P1 is equal to 1 into H divided by 2L. Because formula I have not written here. Okay, this is the constant formula. Okay, momentum P is given by is equal to NH divided by 2L. This is the constant formula. Momentum P is equal to NH divided by 2L. NH divided by 2L. I will use this formula here. Okay. If you are using that formula here, P1 is equal to, put n is equal to 1, 1H divided by 2L. Therefore, P1 is equal to 1 into H value 6.625 10 to the power minus 34 2 multiplied by L value. L value is 1 angstrom. 1 into 10 to the power minus 10. This is P1. This is P1. So many kg meter per second. Kg meter per second. This is for n is equal to 1. For n is equal to 2, this implies P2 is equal to 2H divided by 2L. H by 2L already we got it now. That is H by 2L already we have estimated. This H by 2L is equal to this P1. Therefore, P2 is equal to 2 times of P1. So, substitution calculation, you do it. So many kg meter per second. Now, how much you are getting? P1 3 point something 10 to the power of minus, okay, right, 3.313 10 to the power minus 24 multiplied by 2 means you will get a 6.625 or 626 10 to the power minus 24. Okay, now energy. We want to calculate the energy further. Energy formula. Formula for energy. En is equal to n square h square divided by 8 ml square. This is a constant formula. Substitute in constant formula and get the answer. Okay, this is a formula. Let me write it here. For n is equal to 1, E1 is equal to 1 square h square divided by 8 ml square. This is in terms of joules. This is in terms of joules. Convert in the form of EV. E1 is equal to h square divided by 8 ml square 1.6 so many EV. So therefore E1 is equal to h square 6.625 10 to the power of minus 34 whole square 8 into mass of electron, rest mass of electron, neglecting the relativistic mass, into L value how much? 1 angstrom, correct now? 1 angstrom, 1 into 10 to the power minus 10, that square up to here 8 ml square into 1.6 10 to the power minus 19. This is the substitution part. We had to do the calculation for this. You will get so many EV. This is for E1. For n is equal to 2, you will get for E2. E2 is equal to 2 square h square 8 ml square. But this is already, we found this value. This value is equal to E1. Therefore, E2 is equal to 2 square times E1. Therefore, E2 is equal to 4 times E1. That is equal to 4 into this E1 value. Substitute, get the answer for E2. So many EV. Do it fast. E1 value. I am showing problem number 8 as well as problem number 9, showing the answer. Check it out. 37.6. Sanju, correct. 37.6.